Alright, welcome back everybody. Today we're going to be doing part 2 of our Gray-Scott reaction diffusion in TouchDesigner. This is exactly where we left off at the end of part 1. We're looking at kind of a part of what we're going to be doing today. That's going to be one, adding a render that is spherical and includes wrapped coordinates. We're going to be adding interaction, so that we can use the mouse as a interaction interface for the system. And 3, we're going to be implementing some presets so that we can keep track of interesting behavior that arises. So, without further ado, let's jump into things. So this is where we ended our last session. Now, nothing's changed here. If we reset, we can see that our reaction diffusion system is growing. I'm going to use a different palette that I think is a little bit nicer, and this palette will be included in the Patreon files, so you guys can grab it if you like. I think the first thing that I'm going to do is the rendering with the wrapped texture coordinates, because it's pretty simple and it's a good place to start. So first thing that we need to do is just edit. So let me get my VS Code back up here, and this looks a lot like our shader. Let's edit this, make sure we have the correct one open, and basically what we need to do is just wrap these coordinates. And the reason that we're going to need to wrap the coordinates is so that we can have this applied to a sphere and not have any gaps. So I'll actually just insert a base right now, and we can get the sphere render going actually. So I'll use a sphere, drop down a geo. I'm going to use a Fong for right now, put a Fong material on that. Then I'm going to use a environment, nope, not an environment light. I'm going to use just a regular old light. And then I'll use Control B to open the sidebar, and I'll use a camera viewport for some ease right here. Then I'll drop down a render top, make sure that camera is the camera on the render top, and I will wire our render into our out. So now we have this nice render here. One thing that we obviously want to do is then use this color map as the color map for our shader. So we'll drag and drop that on the material as the color map. And now we can see a little bit about what's going on. A couple things. This render, I'm going to make it, well, I guess I'll make it the same resolution as our Gray-Scott simulation, so that's 1920 by 1080. And if I reset the simulation, we can see that this is actually going and looking pretty good. Some things that we can do to improve could be using a environment light, and then maybe we'll use a movie file in, and I'll grab this man, I hate it when that happens. We'll use navigate to this directory, and I want to use maps, and then I'll use this cloudy ocean, which I'm sure everybody's familiar with. Alt-N to drop a null, drop it on the environment light, call it the environment map, and then we can use a PBR shader as our shader, which can use this as a base color map. Now we should make sure to have a attribute create SOP with normals and tangents on our sphere to make sure that we actually have the information we need to do that render. On the environment light, we can make the dimmer something like 3, so that there's some more light coming in from our environment. And then on the PBR itself, we can mess with the parameters to see what we like. We can also define some of our own parameters. For example, if I use a monochrome, I can maybe use that mono as, let's say, my metallic map. And this way, when I turn roughness or metallic up and down, respectively, that is applied a little bit more to our ridges than others. So we can also use a normal map. And again, use Alt-N. We can drag and drop this on the normal map for our PBR. Turn up the bump scale. And you can see now we're starting to get some nice, interesting shading that looks like there's some ridges being formed. You could even do something like enable the height map. And then displace our vertices. Now, I'm not really going to do this because, well, I don't want to. But it is possible. And so, good to know about. Make the bump map like 5. And I think I'll turn roughness like a little bit down. And then metallic, I'm going to have pretty much the whole way up. And then ambient occlusion. We can actually if we use our height map, our mono as the height map, we can play around with this parallax occlusion, which you can see adds a little bit of depth based on the scale. This is kind of depending on what your compute capabilities are, whether or not this is helpful. I'm just going to turn it off and leave it with just the bump and the normal map. If we use the camera viewport and kind of turn around and look at our sphere, we can see that there's a hole on the top, there's this piece on the bottom kind of. And what we would like to do is try to eliminate some of that. The other thing that we would want to eliminate are the edges. As we can see, because of the way the reaction diffusion operates, the edges are already not super apparent. And so what we can do is to just make it a little bit better, actually texture wrap our vertices in the shader like I mentioned before. So to do that, I'll jump out of here, I'll go into our shader, and we will wrap our texture coordinates. And the easiest way to do that is going to be Alt-click, and we're going to use the mod. And so we'll use the modulo expression, and we'll want everything to be modulo 1. So that's going to wrap our texture coordinates. And then all we should really need to do there is reset our system. We can see that while we still have the hole on the top and the bottom, things are looking a little bit smoother. We don't have as much bunching around the edges, and I think this is a good enough place to stop for the sphere render. So I'm going to leave that part there, but now we have nicely wrapped texture coordinates and a sphere render for our reaction diffusion system. Okay, what is the next step? The next step is going to be the preset system. And what was the last thing that I promised? The interactions. Yes. So give me a moment while I get that bell. All right. Sorry about that. Yes. So the presets and the interaction. Let's do the presets, because that's a little bit more involved. Okay, so we have all of these different feed and kill rates. And so the idea is going to be, one, we're going to put some in a table to have some nice existing presets we can play with. And then we're going to be able to add our own. And so that's going to be the part that we're building right here. Now I'm going to bypass the sphere render because we don't really need it. And I'm going to create a table. And I'll call it preset table. Now I'm going to have it be manual. I'm just going to go add after and add after. And so this will be our feed rate, this will be our kill rate, and this will be our preset name. So I'll add a couple rows and I'll start populating them. So this one will be our default, and that's going to be our current feed and kill rate. So that'll be, just reorder these so that they are in the same order. So that'll be a feed rate of 0.055 and a kill rate of 0.062. Now, what about the next one? Well, we can take maybe bubbles. That doesn't look super interesting. Turing patterns. That looks kind of interesting. So we can try that. 0.042 for feed and 0.059 for kill. 0.042 and 0.059, and then our name will be Turing. And then let's do one more to get started. We can do maybe mazes. Is mazes good? Mazes seems nice. That'll be 0.029 for feed and 0.057 for kill. Okay. So now we have some of our presets. And so there are two things that we want to do here. One is we want to be able to use a menu to select the preset, and two is we want to be able to add our own presets. So both of these are going to require an extension. So I'll open my component editor. I'll create an extension. I'll call it Gray Scott extension, and we'll add it, and then I'm going to edit it. And make sure I can edit it in the right thing here. All right. So now we have our extension class. And so now we can start to work with this. Let's do an add the preset first. So to do that, we can do two things. We can have a pulse that will be called add preset, and that'll be a pulse parameter, just like that. And then we can have a preset name, or we can even call it new preset name. And that should be not a pulse, but a string. I'll move these to the bottom and section this one. And so I will have a test name. And so the idea is when we pulse this, I want to take my current feed and kill rate, as well as my new preset name, and add a row to this preset table. So in extensions, that's pretty easy. First, I'll define a member of this class, self.preset table equals self.ownerComp.op preset underscore table, because that's what our naming is. And so then I can say def add new preset, and that'll take in our self, and we'll return. And then in here, what we need to do is have our f equals self.ownerComp.par dot feed rate, k equals self.ownerComp.par dot kill rate, name equals self.ownercomp.par dot new preset name dot eval, and the reason that I'm using eval here is because it's text and we want to make sure it gets returned as a string. And so then we can use self.presetTable.appendRow, put in brackets name fk, and this should add a new preset every time we press pulse, as long as we have something to actually hit that extension function. And so to do that, we can use a parameter execute. We'll point the parameter execute at our parent component, which we can also give a shortcut, maybe shortcut GS for Gray Scott. And then the parameter that we want to look at is add preset, and on pulse should be checked. We can go in here and edit this, get rid of everything besides on pulse, and on pulse we just want to do parent.gs.add new preset. And that will then use the function that we just created anytime this parameter is pulsed, and that should add us a row with our current feed and kill rate. So let's see, we press pulse, and we can see a new row here on our preset, which is very nice. Now, I don't actually need this, so I'm just going to delete it. But now that gives us our ability to add presets to this table very nicely. Okay, so now we need to add a parameter to allow us to select those presets. And so for that, I'll have a preset parameter, and we can make this a menu. Now, we probably want this before or after our added preset. And now what we want to do is be able to set this menu labels as a function so that we can basically grab these preset table names and have the function that calculates these names also set our menu labels and menu names on this parameter. And we can do all of that from our function extension as well. So go back here to this extension. We'll have another function that's going to be called, I don't know, what should we call it? Maybe something like update preset menu. And so in here, we're going to first create list of all preset names. And then we're going to use list to set menu item choices. So names equals, and this we basically want to take everything in column 0, rows 1 to the end. So we can use self.presetTable to access that operator. .call, and we can use the column that's called name, and then we want row from 1 to the end, and then we can just print that out. Maybe we should call it names since it's a list. So then I'll open my text viewer here, and we want something for adding the preset, like a pulse or something like that. Right now I'm just going to use a text stat, and we'll call parent.gs dot update preset menu. Is that right? Update preset menu. Open close, and then I'll use Control R to run this, and we can see that we do indeed get this list. These lists are cells, and so if we search for TouchDesigner cell class, that will tell us that what we need here is this val member of our cell to actually access this value, which is the name value touring, value default, etc. And so in our extension, we can have another line, names equals, this will be x.val, or to make it even clearer, cell.val for cell in names. And so this should loop through and extract just the cells values from each cell. And so if I run this again, we see that we do get just a list of the 3 names: default, Turing, and mazes. So now what we need to do is set the menu labels to this. So to do that, we can say self.ownercomp.par.preset.menu labels equals names. And now we'll run this again. Run this again. We see that we are still printing, and now we have this list of names as our presets. So let's say we add a preset again. We have this new name, but we don't see any new options on our drop-down menu. And that's because we would need to run this function again with Control-T, and now I see that test there. So what we want to do is basically automatically run this function whenever this table updates, or alternatively, whenever we add a new preset. And so what we can do is in our extension here, we can actually just call self.updatePresetMenu every time we add a new preset. And what this will do is ensure our new preset is added to menu dropdown. And then I'll get rid of this print statement since we don't need that anymore. So now if I have another test, we'll call it test 2, and I add, I see that this appears, and now it automatically appears as my dropdown as well, which is great. So I'm going to just delete these last 2 rows, which I don't need. And so now the last piece of this preset, now that we have some built in already, we want to be able to use these values to actually update our parameters. And so to do that, I will use a little dat chain where we will select rows by index. I'm going to just get rid of that first row. And I'm going to get rid of the first column. So now we have just these 2. I'm going to then use another select. I'm going to select by index rows again. I'm going to drag and drop my start row on my end row. And then I'm going to drag and drop my preset parameter on my start row. And this way, as I select additional presets, this row index is updated, and you can see that I'm grabbing the appropriate values from the preset table. So now we can use a null to end that part of the chain. We can then use a dat2, and I'll make sure that I have a channel per column and that both of my channels are values. Then I'm going to use a rename, and I'm going to rename them to feed and kill. Now I will use a chop execute. That chop execute will be on value change, so I can get rid of all of these others. And I'm going to write an extension function that I will call in here. So we can call it with parent.gs apply preset, and I'll pass in my channel and values to this function. Now I'll just go write this function in the extension quick, def apply preset, and this I will have self as an argument, and then I'll have the 2 arguments that I'm passing in, channel and val from before. Start by typing return. And then in here, we are basically going to just take those two channels and apply their values to the appropriate parameters. If channel.name equals feed, then self.ownercomp.par.feedRate.val equals val. If channel.name equals kill, then we'll have our self.ownercomp.par.killrate.val equals val. And so that's very easy. See if that works. So now we would hope that if I select the maze preset, that these values will update. We see that they did, and when I pulse the entire system, we see that our entire system works again under these new parameters. And as I change the parameters, the system correspondingly evolves, which is great. So now if I use a little network box, I'll call this preset management. Just like that. And we can give ourselves a little bit more clarity by saying parx add preset. And this can be chopx apply preset. And so, using this pretty easy functionality and the extensions, we have this nice dynamic preset system. Now, the one flaw to updating our list of presets when we add a new one is that it doesn't do anything. It doesn't update automatically if we add or if we delete a preset. So we can do that two ways. The easiest would just be to do a dat execute, drag and drop this preset table onto it, and then have table change. Again, we can get rid of all of this other stuff, and on table change, all we want to do is call parent.gs.update preset menu. And now this is going to just call that menu update anytime there's a new function. So, for example, if I set this to mazes, but then I delete this row, now only default and Turing are here because our table test, or our table changed, therefore this dot execute fired, which ran our update menu preset. So now, if I just put mazes back in by using the add preset functionality, we can see that we do have this, and whatever, I'll do a test again, change these, pulse, test is now there, and if I manually delete test just like so, it is removed from the list. So that's exactly what we want, and is a pretty nicely fully featured list. So now we can go back to our default and we can reset our system. Last thing I'll do here is just drag and drop this reset pulse, move it up to the very top. So this is going to be our reset simulation pulse. And now we have the preset system. Now, the last thing that I want to do in this tutorial is add the capability for interaction. So we're going to do that through a panel interaction. Let's clean this up a little bit. Just call that a render. And we'll have this be called GrayScott RD. So to add interaction, what do we need to do? I want to use panel interaction with the mouse for this one. So basically, if I right click and open my parent viewer, I want to be able to click and drag on this and be able to add stuff to my simulation. So to do that, I can use a panel. From the panel, you see all this information that changes as I interact with the parent component, and that's because the panel's component parameter is pointed at my parent. I could say parent.gs instead because that is the GrayScott, or rather the parent shortcut that I gave to this Grayscale tutorial component. So I want the inside U and inside V parameters. Inside U, inside V, and L select. And so that'll be clicking as well as where my mouse is, which is great because that's already into UV. So it goes from 0 to 1 on both directions. So I'm going to rename this null to null mouse, and I'm going to also use a rename chop. And I will rename to my TX, TY, and click channels. Now, in my GLSL vector page, I can drag and drop my TX, TY, and click onto my mouse X, Y, and Z components. And so now, in my shader, we already have this UMouse declared, so we can start to use that here. And so basically, I only want to be able to use this interaction if I'm clicking. So we can say if umouse.z is greater than 0, which would basically say if clicked, then we want to do some things. So the best way to do that is to look at how far away our current pixel is from our mouse. So we can use the distance function, and we can use our UV and our umouse.xy as the two parameters. And then we can use an if statement and say if distance is less than some small value, then concentration, or rather new concentration dot g equals 0.5. And so basically we're going to change the concentration of chemical B based on the mouse. As you remember, there's a chemical reaction that is occurring when 2 of B takes 1A to create 3B. So by adding B to the simulation with the mouse, we're basically going to jumpstart some reactions wherever we touch. Now, okay, we can kind of see this happening, but it looks a little funky. So let's change a couple things. First, we want our resolution to be the same as our display width. So I'll have my X and Y resolution be the width and height. I also want the look tab to have the background top parameter set to out1. This ./out1 means the operator named out1 in the level 1 below the current level. We don't actually have one of those right now, so I will just drop down and out. And now that we have an out1, I can see that the viewer for my container is now with this background. So there's a little bit that we want to change. First, we probably want to have the size or the radius be a variable or a uniform. So you can say u mouse radius, and then I'll set it to 0.01 maybe. In my GLSL, I'll add that uniform as a float, u mouse radius, and I'll use that instead of this 0.5, which is pretty arbitrary. You can see that my mouse click is now much smaller. So the other thing that we want to do is scale the UV by our aspect ratio. So we can have a vec2 and call that mouse pose equals umouse.xy, and then we'll use mouse pose.y times equals, and then this will be utd output info.res w divided by u td output info.res.z. And so this is going to be aspect corrected. And if we change this u mouse in our distance to our new mouse pose that is aspect corrected, seems like something was wrong. Something is wrong. And the reason that we're having this problem is because we actually don't need to aspect correct the UV one or the other. We actually want to aspect correct both of them. And so to aspect correct both of them, what I can do is define two other variables. So one will be my vec2, and I'm going to call it texel, and that's going to be utd output info.res.xy. And this will be our texel dimensions. Then I'm going to have another vec2. I'm going to call this diff. And this is going to be my uv minus umouse.xy. And then here I'm going to divide this by my texel. And the reason for this is going to be that is actually our aspect correcting on both of them by aspect correcting the difference itself. I can get rid of this. And now, instead of having the distance function, we can just dot product difference against itself. And then we can use this mouse radius, again, to determine whether or not we're close enough. So because we're dividing by the texel, this mouse radius actually needs to be much larger, because when you divide by a very small number, you get a very large number. And so you can basically think of this radius as like the pixel radius. If I make this full screen, reset it again, we can draw now with the mouse and have our results added to the simulation. And it works without the noise input too, although it's clear that when we do that, our resolution is wrong, so I should remember to set the GLSL resolution to the resolution from my parameter. And so now I reset, and because I don't have the noise connected, there is no activity at all. But then as I click and drag with the mouse, our reaction-diffusion system begins to populate. And so with that, you now have this component. Let me put an annotate here. Panel interaction. And we have this component. I can reset it, and we can draw. And then we can also, of course, change the parameters. And we can also fine-tune these feed and kill rate parameters on our own. Obviously, changing the passes is also something. And so let's say this is interesting. We'll reset. And you can see that we're kind of now getting a better understanding of what the entire reaction-diffusion system can do, and we have a nice way of interacting with it and adding our own presets. So, I think that's a good place to stop for this part of the tutorial. Our next and final part is going to be taking all of this to the next level and thinking about ways that we can begin to do more advanced systems, more detailed and anisotropic textures, and I'll work through or show you some more of the work that I've done using this technique. So with that said, thank you so much for following along so far. I hope that you got some good stuff out of this, and thank you again to everyone who is supporting me on these Patreon videos. It means a lot, and yeah, thank you very much. Until next time, happy creating, and I will see you later.